This is Med Math and Beyond Part 2, dosage per kilogram. We know that weight for drug calculations needs to be converted to kilograms from pounds, and we know that each kilogram times 2.2 equals the number of pounds. In other words, for every kilogram, you have 2.2 pounds. For example, a 100 kilogram patient weighs 220 pounds. You can also get to the same thing by taking the pounds of your patient and divide it by 2.2 to get the kilograms. For example, a 154 pound patient divided by 2.2 is 70 kilograms. A shortcut you can use to get there a little easier is to divide the weight in pounds by 2 and then subtract 10% from the answer. For example, a 160 pound patient, you divide that by 2, you get 80. 10% of 80 is 8, and if you subtract 8 from 80, you get 72 kilograms. If you do the math, it's actually 72.7, but 72 is certainly close enough for our purposes, especially in EMS, making rapid calculations. If we can get within within 1 kilogram, we're certainly close enough for our purposes, and we often round slightly to make the medical calculations or the medication calculation a little simpler. When a protocol or our orders indicate that a dose is going to be based on weight, you must determine the weight in kilograms and then multiply that times the drug amount to get the desired dose. For example, the weight in kilograms times the milligrams would be equal to that desired dose that we talked about. For example, rocuronium. A common dose for rocuronium for paralysis is 1.2 milligrams per kilogram. You're preparing to give rock to a 9-year-old patient. A typical 9-year-old would weigh about 66 pounds. So we're going to use the same basic formula that we use for a push medication once we have determined the weight in kilograms. So we're going to take that desired dose times the volume we have on hand, and you're going to divide it by the amount of medication on hand. For example, your 66 pounds divided by 2.2 is equal to 30 kilograms. We said that our dose for rock is 1.2 milligrams per kilogram, so we take that 1.2, multiply it by 30, and we get 36 milligrams. Now we know what our desired dose is. We can multiply that times the volume on hand. In this case, we have 10 milliliters. We can divide it by the total medication that we have on hand, which is 100 milligrams in this container, and we know that what we need to draw up is going to be 3.6 milliliters. So our desired dose divided by the concentration, again, this is that other shortcut method to get there. If we know what we want to give is 36, and we have 10 milligrams in each milliliter, then we can divide those and we get 3.6 milliliters. Two different strategies to get to the same answer. So you look at that 3.6 milliliters, and you're going to want to use a 10 milliliter syringe to be able to estimate that, and you're going to draw up just 3.6.